I'm gonna try to video today. First part, or I tried to it kept crashing and I just gave up. So if this goes away and I don't notice it, y'all tell me that it went away so that I'll stop and try to restart it. This little box down here, if it disappears, let me know so that I can try to restart the video. Because sometimes the calculator skills, sometimes it's better to watch it again and see, to remember what buttons to press and stuff. So today we're going to be doing linear systems again, but by this method called RREF, which is the graphic calculator, is what we're going to be using. So I think this is lesson 14 for the thing. It doesn't really matter what number it is. It's the next lesson, linear systems by RREF. RREF stands for reduced row echelon form. You don't have to know that, but that everybody always says, what's that even stand for? It's a reduced row echelon form. What that is using a matrix to solve a system of equations. And the matrix that we use is called an augmented matrix. Yeah, it's a big word. Yeah, man, that's a big word. All right, so it's called an augmented matrix. All that means is we're going to put a system of equations into a matrix, and we're going to get back something that looks like this. You know, it'll have a number over here. We'll call it 8, and then a number over here, and maybe it's -5. The augmented matrix. This is reduced row echelon form for a 2x3 matrix. How is that 2x3? What do I mean by that? If you can, 2 rows and 3 columns. 2 rows and 3 columns. Top row has 3 pieces in it. Bottom row has 3 pieces in it. So it's 2 rows by 3 columns. So that's how you decide the size of your matrix, is by rows and columns. So rows first. So 2 rows, 3 columns. This is an augmented matrix. What that does is, if we can get our calculator to do the reduced row echelon form of a system in a matrix, then this last column here is our ordered pair for an answer. So the answer, this shows us that the answer is x is 8, y is -5. We're going to see that it kind of makes more sense once we get a system to do this with. But what that ends up giving us is x equals 8, y equals -5, or the ordered pair 8, -5. That's what the reduced row echelon form gives us. Notice the 1s and 0s in there. They are in very important spots. What it really basically is this first column is the x column. The second column is the y column. And we do 3 variables. There'll be a third column. It's z column. And then you'll have a number on the end. What this first row says is that 1x plus no y's is equal to 8. So that's where we get x equals 8. And this says no x's plus 1y is equal to -5. And that's where I'm getting y is equal to -5. So this is what we want to end up with once we do the RREF with our calculator. So I'm going to show you how to do that with a system of equations. So we'll start with something like what we've done before. So the first example is going to look like one that we've done by elimination, but we're going to use the calculator to do it. We know how to solve it by elimination, but this is just another method for solving it. So let's say we had 8x minus 10y is equal to -20. And the second equation is -8x minus 7y is equal to -14. Okay. Do we see how that would be easy to do with elimination? That we could cancel out the x's real easy and get it if we want to do it with algebra. To do augmented matrix with your calculator to solve it, it's got to be in the same form that you would have it to do elimination. That's why I bring that up. Okay, it's got to have x and y on the same side and in the same order: x, y, then the numbers. Okay. Then what we're going to do is, with our calculator, we're going to put an augmented matrix in. So the augmented matrix And I keep mentioning that word because there are questions on your EOC that'll ask you just to take a system and put it into the augmented matrix. And that's the answer. And you know, like that's the easiest thing in the world. I hope they ask you 3 or 4 of those, but they're probably not. I don't want to ask you one, most likely. But the augmented matrix, look at our system here. We got how many rows? 2. Look at our columns. X, Y, answers. So we got 2 by 3. So our augmented matrix is going to be 2 rows by 3 columns. So the top row is going to be the numbers from this equation. 8, -10, -20. 8, -10, -20. The second row is going to be the numbers from the second equation. -8, -7, -14. All right, so that's the augmented matrix. We're going to put that matrix into our calculator. So grab your graphing calculator. Excuse me. So here we are. I'm just on the regular calculator screen. I'm not doing anything yet. All right. So the way you get to the matrix menu with your calculator is you press the blue second button, and then right here beside the sign button is the X to the -1, and above that in blue it says matrix. So we're going to hit second and then matrix right there. So that button is highlighted in red. And then we're going to go over to edit because we got to put a matrix in there. So when you're changing something, you go to edit. So we're going to press the right arrow. Yours may have some stuff written there already. I'm just going to hit enter on A, and mine just doesn't have anything in it yet. Yours may already have something there, and that's okay. It does. Don't worry. Now, what size matrix do we need to build? So we're going to write it right here beside. That's the size. So we're going to go 2, enter, 3, enter. And notice how it builds it underneath there. It makes one that's the right size. Okay. Now I'm going, after I hit enter there, I'm ready to put my numbers in there. Yours may have numbers already. That's okay. Just type in the new number and hit enter, and it'll erase the old one and put the new one. Okay. So mine's got all zeros in there. So I'm going to type in 8, enter, -10, enter, -20, enter. So there's my first row. And my second row started with -8, -7, and -14. Enter. Make sure before you leave this screen that you got everything in there in the right place with the right sign. Because if one thing has the wrong sign on it, messes everything up or makes it a completely different problem. Okay. So once you've done that, we're going to hit second and then the mode button, which is right beside it. That gets us back to the regular calculator. So your calculator is remembering what you put into the matrix A. And so anytime we use that matrix, it's going to remember that one. So what we want to do now is tell it to do the RREF on that matrix. Put it in reduced row echelon form. So we're going to hit second matrix again. And we're doing some math with it, right? Because we're doing the RREF. So we're going to press the right arrow key to go to math. And we're going to scroll down through this list until we find RREF. Should be down toward the bottom. Scroll to where mine is at option B. And depending on what operating system you got on there, where it'll be. B is where mine's at. But it just says RREF. Make sure you select the one that says RREF and not the one that says REF. Okay, because it makes a difference. REF doesn't get it the zeros all in there. It puts the ones in certain spots, but it doesn't put the zeros in there. So it's like, I like to think it's halfway done, is the way I think about it. It's just reduced, or it's just row echelon form is what it stands for. Reduced row puts the zeros in there, gets it in the smallest terms. That's, did you get where you need to be? Okay. All right. Anybody else have not to that spot? All right, so once we get here, we press enter. And then we got to tell it what to do that with. So we need to pick which matrix we put that in. So I'm going to hit second matrix. And then option 1 is the A. That's the one I put mine in. And you can close the parentheses or not. It doesn't matter. I'm just going to hit enter. And it does all this row reduction stuff and gets us into this form. And the matrix that we get as a solution after we've done RREF is 1, 0, 0, 0, 1, 2. What does that tell us about x? X equals 0. What does y equal? 2. So we get the ordered pair, 0, 2. If we had done this system with elimination or substitution, we get the same answer out of that. Okay. So reduced row echelon form breaks that down, gets us that ordered pair that is our solution. Okay. Did everybody get that answer? We're going to do several more, just get the process down and kind of step by step, not me stopping him in the middle as much. Okay. Let's try another one. 9x minus 6y equals 30. 8x minus 12y equals 20. So my matrix that I need to type in is 9, negative 6, 30, 8, negative 12, 20. You don't really have to write that down anywhere. Just know that that's what your matrix should look like once you type it in. Okay, so let's go through how to get there again. So I'm going to hit second matrix, go over to edit, and pick which one you want to put it in. I'm going to use A again because it's the right size. So I don't even have to change the size anymore on that. And then I just type over the numbers. So I got a 9, a negative 6, and a 30. Then I have an 8, a negative 12, and a 20. Check my numbers, 9, negative 6, 30, 8, negative 12, 20. So check to make sure everything's the right spot, the right sign. And then I'm hitting second mode to get back to the regular calculator screen. And here's the shortcut that we can use. Because we've already found that RREF, we don't have to go through and find it again. If I just press the up arrow until that's blinking on that, mine's colored, so it turns blue, and hit enter, it's like copy paste with your calculator. Press the up arrow until it blinks, and then hit enter, and it copy pastes it to that. And because I put it in the same matrix, I don't even have to go find the same name anymore. I just hit enter here, and it'll crank out a new answer because I've changed the matrices. Okay. If that bothers you, you can hit second matrix, go over to math, find RREF. Oops, I did the wrong one. Second matrix, math, RREF. I hit the up arrow one too many times. Second matrix, matrix A. Okay, that's the step-by-step way. There's several button pushes to do that. That's why I like to press the up arrow and hit enter, and it copy pastes it there, and then I'm hitting enter again. And there I have my ordered pair, or my reduced row matrix is 1, 0, 4, 0, 1, 1, and my X answer, Y answer, ordered pair is 4, 1.
As long as any equation in the elimination form.
Mm-hmm. Yes, absolutely. Works wonderfully. Let's look at this one. Because, all right, so to kind of piggyback off what Blake was saying, elimination form, we can use this method to help us solve. What happens? What are our scenarios for systems of equations where we're solving by substitution or elimination? or drag. There are things that can happen. No solution, one solution, or infinite solutions, right? We had those three things can happen. Same scenarios here, it's the same kind of problem. So we could have any of those three things happening. The first two examples we did had one solution because we found an ordered pair. Well, what did it look like when we were doing elimination or substitution and we got one of those weird ones? What happened to the variables? They went away, right? Well, we don't even have any variables in our matrix, so it's we can't rely on that rule. So what we got to look at is our reduced row echelon form of the matrix. So let's look at this system: 4x plus 5y equals 1. And then let's do 4x plus 5y equals 4. So I think you guys can look at that and tell me that it would have no solutions. It makes sense that it have no solutions because you got the same thing twice and they equal different things. Can the same thing ever equal something different in math? No. So we know that this should have no solution. So let's look at what's it look like in the matrix form when there's no solution. Okay. So we're going to do that augmented matrix thing, 4, 5, 1, 4, 5, 4. So let's go to our matrix and put that in. Go to edit. And I'm just using matrix A again. 4, 5, 1, 4, 5, 4. You guys can get that put in. And then we're going to run that RREF on matrix A. That's where I put it. Notice, well, it doesn't necessarily matter that there's a decimal. What should be right here? A 0. There's not a 0 there. What should be right here in this bottom row? A 1, because this is supposed to be x equals a number, and this is supposed to be y equals a number. What does this last line say? 0 x's plus 0 y's is equal to 1. What's 0x plus 0y? Is 0 ever equal to 1? Never, right? So that bottom line there shows us that this has no solutions because the reduced row, it doesn't really matter that it had a decimal there. It matters is that what matters is that bottom row. That bottom row, we've got 0 x's plus 0 y's is equal to a different number other than 0. That row right there tells us that this is no solution because the bottom row is false. 0x plus 0y can't equal 1. 0x plus 0y, what's the only things that could equal? 0, right? So that's the reason it's no solution in the matrix form. Let's say we had negative x minus y is equal to negative 6. 3x plus 3y is equal to 18. So a little different system, but it's still in the elimination form at, where you got x and y on the same side. So that means we can use the augmented matrix to solve it. Negative 1, negative 1, negative 6, 3, 3, 18. So I'm going to put that in and do RREF with that. Yeah. So let's go through the steps again to put that in. So I'm going to hit second and then the matrix button, which is the X with the little negative 1 exponent. We'll go over to edit. And I just picked the first matrix there. You've got 10 to choose from. I just pick the first one every time for now. And it's a 2 by 3 again. And then we're going to put in the coefficients. So we have negative 1, negative 1, negative 6. And then the second row, 3, 3, and 18. Is that what it was? Okay. So once I've done that, I check to make sure everything's in the right spot with the right sign. Because it mess it up if it's not. I'm going to hit second. mode, get back to the screen, the regular calculator screen, and then I'm gonna hit the second matrix over to math and picking RREF unless I do the copy paste trick. Then second matrix and select matrix A, which is the one I put it in, and then hit enter. And we get a weird looking matrix. The reduced row echelon is 116000. Well, that's not the form that's reduced row echelon that we're used to. Look at the bottom row. 0x plus 0y is equal to 0. Is that true? Yeah. So that's an infinite solution. Or infinitely many, whichever way you want to say it. Infinite solutions, infinite many, whatever, something like that. If you were to do this one with elimination or substitution, all the x's and y's would cancel out and you would get the same number on each side. If you do elimination, you're going to get 0 equals 0, just like the bottom row says. If you do substitution, you get like 6 is equal to 5 or something like that. Or 6 is equal to 6, not 6 is equal to 5. You get the same number on each side, just like the bottom row has the same number all the way across.
Would it be infinite solution?
It won't do it that way. The way your calculator runs the algorithm to do the reduced row echelon, it always moves the zeros in the first column down to the bottom. If you were to do row operations by hand, which we don't do in Algebra, there's not a standard that we need to do. The protocol is to move the zeros in the first column down to the bottom out of that. So it won't ever have it that way. Good question, though. Okay, so 2 variable systems, doing it this way. Well, we didn't do 3 variable systems by hand. You're welcome, because they take about 1.5 pages of paper apiece. And if you make one mistake on the first step, everything you did on the next 1.5 pages was no good. You got to start over. Or if you make a mistake in the middle step, well, everything you did after that is wrong. You got to start back at the middle step. So that's you're not going to have to do those by hand on the EOC, but you will have to solve some of them probably on the calculator portion of the EOC. So I want to show you how to do those. They're really easy. It's the same thing. It's just 3 variables. For example, 3x plus 3y minus 2z is equal to negative 18. Negative 3x plus 5y minus 4z is equal to negative 10. And then the last one is negative 3x plus 2y minus 5z is equal to negative 19. Okay, but what's different?
Yeah, 3 columns. Well, 4 columns and 3 rows.
Yeah, it's a 3 by 4 because you got 3 rows and 4 columns. So our augmented matrix will be 3, negative 2, negative 18, negative 3, 5, negative 4, negative 10, negative 3, 2, negative 5, negative 19. And then we're going to do RREF to solve that. So going through the steps, second matrix, go over to edit. I'm just going to edit matrix A, but I'm going to change its size. Instead of a 2 by 3 now, I'm going to do a 3 by 4. And then I'm going to put in that matrix that we had there. So 3, 3, negative 2, negative 18. That's the first row. Negative 3, 5, negative 4, and negative 10. And then negative 3, 2, negative 5, negative 19. lot more stuff to put in, so I'm gonna make sure on my signs there, 3, 3, -2, -18, -3, +5, -4, -10, -3, +2, -5, -19. Just making sure I've got all the signs and things the right way, because I had to enter, 12 things there, so very ups the probability of getting one of them wrong at least. All right, so what do I do next? Second mode, second matrix, math, all the way down to B to RREF, and then I just need to tell it what to do that to. So second matrix, I put mine in A. You may put yours somewhere else. So put mine there, and then I hit enter. We get the answer back. 1, 0, 0, -3, 0, 1, 0, 1, 0, 0, 0, 6. Woohoo! So what's X? What's Y? And Z? 6. The answers to a 3-variable system. That should have a 1 in it. Yeah, I think I said it and I just didn't write it. Thank you for catching that. Ordered triple is the way that the answers are written. And we're ordered pairs with X and Y. Ordered triple, X, Y, and Z is the way that these are typically written. -3, 1, 6, like that. And if they ever change the letters to different things other than X, Y, and Z, it's always alphabetical order with the letters. Is the way the ordered pairs and ordered triples go. With the 3-variable systems, the bottom row still tells what's going on. If your bottom row has a 1 in the 3rd spot and then a number over here, that means you got answers. If the bottom row has all zeros except for the last spot, what is it? No solution. If it's all zeros all the way across, that's the infinite solution. Okay? So setup is all the same, just the size of your matrix is what changes. All zeros on the bottom row, always, no matter what size. If you did a 15 by 16 matrix, something that large, but if you did the bottom row, if it had all zeros all the way across, infinite solutions. It has to be all zeros. That's right. Can't be all of another number. It'll be all zeros or something with a 1 there. Okay. Good question. All right. Pretty straightforward thing. All right. Got some practice here with this, and pretty straightforward and easy. Just be careful that they're in the right form before you do the matrix. Okay. Yeah. We will have a quiz over this tomorrow, or whatever the next day we're at school. Hope it's not tomorrow, it's on Monday. That's what I'm hoping for. You won't come Monday? No. Well, then it's Tuesday on Monday. Set up systems. Think a little bit. On 21, 22, 23, and 24, got to think a little bit there. A few word problems there mixed in. I think 21 is pretty easy to set up.